Hello viewers, welcome back to the channel. Today we will understand how Takt, lead, and cycle time are used to improve a process. Please like and subscribe and hit the notification bell so you don't miss the next videos. Let's get started. First, let's do a quick reminder. Takt time is the available factory time divided by customer demand. Cycle time is the time it takes one part to go through one process in a factory, and lead time is the time it takes for one part to go from beginning to end, passing through all the processes in a factory. Let's now develop an example where these measurements will become handy. So a business owner of bag factory has called us to help him out. This business consists of a simple three-step process. Process 1 is open an empty bag. Process 2 is weigh 50 grams of goods. Process 3 is seal the bags. We also know that the factory works one 8-hour shift from Monday to Friday. It works 20 days a month. Employees have a 45-minute break for lunch and 15-minute daily production meeting. We also know from a customer that the demand is of 25,000 units per month. So now that we have all this information, let's put it in a simple table to make it easier. And we're going to calculate our first measurement, takt time. We know the demand, 25,000 units. We know that the factory works 20 days a month. It has one shift, and every shift consists of 8 hours. We know that it has a break that's 45 minutes, which is 0.75 hours. And it also has a production meeting of 15 minutes, which stands for 0.25 of an hour. So our available time is 504,000 seconds. Now that we have available time and demand, we can calculate takt time, which is 20.2. Our customer made a video of how the production line works. Now let's take a look and we'll calculate the second value, lead time. To calculate lead time, we have to follow one bag from beginning to end. We will put some arrows in the video and we will follow each of the two bags in this case. Let's follow the blue arrow and the pink arrow. Remember, we have to put a timer to every arrow so we can measure how much it takes for that bag to be filled from beginning to end. For our example, we will be following bag, blue bag, and the pink bag. That's an output for the blue bag. So the blue bag took 31.2 seconds. And the pink bag took 48.5 seconds to complete a complete lead time. So now we can calculate our average lead time. In our case, 54.9 seconds. It is also very useful to calculate the standard deviation of these measurements. For our case, it's 16.5 seconds. We will understand how standard deviation will help us improve our processes further. We're going to make a series of videos where we speak about that. For now, we will be prompting out standard deviations, but we will not do any calculations with them. Now, let's take a look at our second measurement. In this case, we're going to measure the total cycle time of the process. We will focus on the right side of the video and see how much time it takes for one bag to complete the process, or how much output does the bag factory can deliver. We will calculate the average cycle time of the whole process. In this case, it's 20 seconds. Now, let's start doing our first analysis. We measured 5 times and we have average times standard deviations, and we will put the takt time in the bottom. So let's bring out the lead time. Our average lead time is 54.9 seconds, and takt time is 20.2. Lead time is greater than takt time. This is a clear sign that there are opportunities inside the process. Let's bring cycle time. Cycle time is 20, and takt time is 20.2. If the cycle time is lower than takt time, the factory can comply with customer demand. This is very important. This is the very first important calculation we have to do. A big misconception is that if lead time is greater than takt time, the factory will not comply with customer demand. This is not totally true. So here is where lead, cycle, and takt time start making sense. Let's now dig one layer down and let's calculate the cycle time for every process. We will go to the first process, which is the back opening process. Output, 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 output. Our average cycle time is 5.8 seconds. Let's now bring our second process, the backfilling process. Our average cycle time for the backfilling process is 18.1 seconds. Let's take a look at the final process, the closing bag. Our average cycle time for this process is 10.1 seconds. So now, let's place all this data in a table. We see that lead time is 54.9 seconds, back time is 5.8, backfilling 18.1, back closure 10.1, and the total cycle time is of 20. When you see that lead time is so much higher than total cycle time, that is an indication that there is a lot of waste in the process. We will talk about waste in next videos. If you want to know about waste and all it takes and how when you measure it you can improve processes, please leave your comments below so I can put on that video. Data in a table looks nice, but I prefer to look at this process as a plot. So let's bring this same data in a plot. To the back factory, we'll draw a line where we're going to have our takt time. Now we will bring each of the cycle times into a bar graph. And this is how it looks. It looks way much nicer. And now we can see a lot of things here. First is that all the graphs are below the takt time. That's why we can't comply with customer demand. But you can see that there is an opportunity in a back open. There's a big blank space between the green bar and the red line for the takt time. So, what could we do to improve this process? First of all, let's keep looking at our graph. Let's try to optimize this cell just by looking at the graph. We now know that the back open time cycle is 5.8 seconds. We also know that the back closing time is 10.1 seconds. If we add them up, that is 15.9 seconds, which is lower than our takt time. Let's take a look how that looks in a graph. We take that, we put it there, and we take the back open and the back close. From the times, we can say that we could optimize the cell and we could rearrange and we could have the same operator which opens the bag to close the bag. Let's take a look how that will look in real life. Operator 1 is now opening the bag. Operator 2 starts filling the bag, while operator 1 keeps opening bags. In this cell rearrangement, once the operator 2 finishes filling the bag, it will deploy the bag to operator 1 again so he can close it. Now operator 1 is closing the bag, and he still has time to continue opening bags. Continue opening bags. In further videos, we will talk about many other things. We will talk about waste elimination. We will talk about rework. So please subscribe to my channel so we can get those new videos posted. We can see that the cell rearrangement is great. There is no delay on the process. So how much have we improved? We have a new graph, which is the bag open plus bag closure process with the 15.75 second cycle time. And we have the bag closure, which remained the same. Let's bring up some of the data. Cycle time for all of the processes is still below takt time. That means that we are complying with customer demand. We also see on the video that one operator has been reduced. So that's a 33% labor cost improvement. We could see again in the video that inventory went down. We used to have 3 parts waiting to be filled. Now we only have 2 parts waiting to be filled. That's a 33% improvement. Old lead time was 54.9 seconds. The new lead time is 26.4 seconds. That's a 52% improvement. So now that we put the table, we can see how much we have improved this process. There is also a very nice way to understand this improvement, and it's called a value stream mapping. Don't miss that video that's going to be coming soon. So if we wrap it up, our bag factory optimized production cell complies with takt time, had a 33% labor cost improvement, had a 33% inventory improvement, and a 52% improvement in lead time. Since we made all this savings, our customer decided to make a great marketing campaign. So new orders have arrived to our process. One new customer is demanding 1,000 units per day. Can our bag factory deliver? To answer this question, please follow part 2 of the video. I hope you're liking this series. Remember, like and subscribe and hit that notification bell so you can be announced when the new video comes out. Thanks very much for watching and see you on part 2.